Today, we are going to look at chemical equations. So before we can actually look at the equation on the bottom of this sheet here, we need to make sure that we know how to count elements. So we are going to do some parts and pieces first. So let's look at this first example here. Here we have O2. And the question here is, what element does the O represent? So we've used this one in class the last several days, but if not, you could find the element O on the periodic table and see that O is oxygen. Now this question, it actually doesn't ask how many atoms are there of oxygen. And like we talked about in our notes yesterday, this 2 is a subscript, and the subscript tells us how many oxygens there are. So if you look at the directions, it says circle the subscript. So that one is a subscript. Okay, let's look at the next one here. It's CO2. This is carbon dioxide. And it says circle each subscript. So we have a 2 here. And now it says how many atoms of each element are in the formula shown. So because there's no subscript after the carbon, we can assume that there's a subscript 1 there. So there's 1 carbon in this formula. And then the subscript 2 on the oxygen means that there are 2 oxygens. So notice the subscript is going to come after the element. Ooh, we've got another thing here in the 5H2. So this 2 after the hydrogen as a subscript, that tells us how many hydrogens there are. But then in front, this 5, that is called a coefficient. So whenever we take a look at this hydrogen, the 2 means that for every atom of hydrogen, there's actually 2 there. And then what the 5 tells us is that there are 5 of these H2. So there's 3, 4, 5. So if we looked at just one of the hydrogen molecules, that would be 2. But because we have 5 of them there, we're going to do 5 times 2, and there are 10 hydrogen in the formula as shown. So again, this number in front is called the coefficient, and the number here, 2, is a subscript. Okay, so let's take a look at this next one. We have 2C2H6. So let's circle our subscripts again. 2 carbons and 6 hydrogens, and we'll put a square around the coefficient 2. So without drawing this, because this is a little bit more complicated to draw than the hydrogen, we can think, if you think about it like a math problem, this 2 distributes to both the carbon and the hydrogen. So we have 2 carbons twice. So 2 times 2 gives us 4 carbons. We have 6 hydrogens, but twice. So 6 times 2 is 12. All right. And now we have our most complicated one we're going to look at. Let's look at our subscripts first. We have a 2 after the Na. Na is one of the elements that it doesn't really make sense. The symbol Na is for sodium. And then we don't have anything as a subscript for sulfur, so that means there's 1 of them. And then we have a subscript 4 on the O, which remember again is oxygen. And this time we have a coefficient 2 in front. So then when we answer the question of how many atoms of each element are in the formula shown, for sodium we do 2 times 2, which is 4. For sulfur, it has a subscript of 1 that's not written there. So 2 times 1 is just 2. And then last but not least, for oxygen, we have 4 of them twice. So 4 times 2 is 8. And it's very important you can count the elements before we look at the equations. So those were some different elements and compounds. So now let's look at this for a chemical equation. So in a chemical equation, what you're going to see is there's always going to be something, an arrow, and something over here. Now, sometimes you might have one thing on the left side of the arrow. Sometimes you might have 2, 3, and same for the right side of the arrow. There could be a lot of different things written there. But what we want to always find first is that arrow. And that arrow is kind of like a math art equal sign, and that means yields. And what it does is it separates the starting materials from the finishing materials. The next thing that we can find here are the things on the left side of the arrow. These are called reactants. And the reactants are our starting materials in a chemical reaction. So in this case, we start with element of magnesium and an element of oxygen. And on the reactants are always on the left side of the arrow. On the right side of the arrow are our products. And in this case, there's only one product. But as I said earlier, there could be more than one in other equations. And then if we take a look at this word subscript, remember a subscript is the thing that's written after an element. So the 2 here is an example of a subscript. And the other vocabulary word from above was coefficient. And coefficient is a number like this that comes in front. Awesome. So again, to review the vocabulary, reactants are always going to be on the left side of the arrow and products on the right side of the arrow. The arrow means yields. Subscripts are small numbers that come after the element, and coefficients are big numbers that come before the compound. And what we're going to have to do in this unit is we're going to have to be able to answer the question, is this equation balanced? And what that means is, do we have the same number of each element of the reactants as we do in the products? So I like to make a little bit of a chart and put like R for reactants and P for products. And then I like to list the different elements that we have. So we can see that we have the symbol Mg, so that's the element magnesium. And we have an O, that's the element oxygen. And what I want to do is I want to count how many of each of these I have in my reactants and in my products. So for magnesium, there's no subscript, but there is this coefficient 2. So that means that I have 2 magnesiums in my reactants. If I look at oxygen, I have a subscript 2, but no coefficient. So again, I have 2 oxygens in my reactants. If I look at my products, in the product MgO, I have no subscripts, but I do have this coefficient that applies to the magnesium. So I have 2 magnesiums in my products. And then this 2 also applies to the oxygen. So I have 2 oxygens in my products. And so to answer, is it balanced? We need the same number of magnesium atoms in our reactants as in our products. And we can see here that we have 2 magnesiums in our reactants and 2 in our products. So our magnesiums are balanced. If I look at my oxygens, I have 2 oxygen atoms in my reactants and 2 in my products. So that is also balanced. And so, is this equation balanced? This is a balanced equation.